Here's something. Okay, there was 2 centimeters at 60, right? That's what X was? Take my time and do it right this time. That's my X. I go to the end of that. And Z was 45 degrees the other way, negative 45 degrees or 315 degrees, but we'll do negative 45. You guys got negative 50, but we're going to say negative 45 is okay with you? Okay, so I've got to flip this over so I can figure out what it is. And so that would be right about here, right? But I'm not going that way, I'm going the other way. Yeah. So I'm going, and it's 1 centimeter. I'm going this way, 1 centimeter. And so then how do I measure my resultant? Magnitude direction. So I put my ruler down here. There's my resultant. And my resultant would be, according to me, 2.4 centimeters long is what I'm getting. 2.8 is a little extreme over there. Hey, stand by it. Go, hey, whoa, how do you know mine's wrong? Mr. Redney, I don't see accurate drawings up there. That's not what you did in that last one. I'm a little embarrassed for you. Now my angle.
90 degrees.
Ooh, yeah, you're definitely off on what I got. I'm at closer to 80. I'm at 79.
Yeah, 80, yeah. I think I drew mine too.
79 degrees. But I got a weird corner here. Like this corner is suspiciously not great. Clearly got an issue there. Good? 79 degrees? What'd you get?
I got 83 yesterday.
83 degrees? 2.4 at 83 degrees? That's fine. You at 88 or whatever, 90 degrees? That's a little much. It's a little much. Not massively. We can live with it. And honestly, we're not going to spend much time drawing vectors like this. The real point of this is I want you to be able to think about what we're doing. What we're doing is we're pretending like an ant's walking on this line, and then it's walking in this line. The question is, how far is it from where we started? That's what I want you to get for this. We really need to get for this. All right. With that in mind, everybody do number 6. What happens when I have a 2x?
Multiply by 2.
Multiply what by 2? Okay.
And the directions?
Okay. What's the reasoning? It's math class. We need reasoning.
No, I think it's just the magnitude.
Why just magnitude?
Because if they're like the ant walks 2 centimeters, but it's two of the x.
Right. It would walk like this.
Forward, but that way, yeah.
And then stop here. Stop with quotation marks. And then it would walk another one like this, right? Yeah. Same angle, same thing. It's 3-4 centimeters long, right? And so you don't double the angle, you just double the distance, how far it goes. Or you can just draw 2 vectors if you're really kind of crazy and want to have fun that way. You're good? You do physics on your own? How are you not in a physics class?
Because I'm a small.
You're in a trig class? What do you take? You take chemistry? All right, I'll let you off the...
I really don't like physics.
What? You do physics on your own time and you don't like physics?
Yeah.
There's a word for that. It's masochism. Second of all, you're not doing it right if you don't like it. I mean, physics is fun. Chemistry. Oh. No, I'm kidding. Chemistry is good too.
Chemistry is my favorite subject.
Okay, then you're really going to like physics. You just don't know yet. Traditionally, if chemistry's favorite subject, physics, you're going to like physics better. Traditionally.
Why?
because chemistry requires problem-solving skills and some mathematical skills. Mathematical reasoning is a better way to say it.
Yeah, well,
That's all physics is. There's no memorization, no nothing. We're in the whole. We just shed all that having to remember anything stuff. We just go right to how's the universe work.
Oh, that's definitely not like the physics I've done.
I would imagine. Okay, I'm gonna do y. I'm gonna do y. So I'm gonna into this. I need a y. So x, and now into y. And y was, I think, 135 that we came up with. Was it 135? Just double checking
Yeah,
somebody.
it was 3 centimeters.
3 centimeters. Whoa. Thinking is not good. Don't do it. Ah. Wasting my time playing with it. 3 centimeters. See if I can do just 3 centimeters this time. Now, traditionally, you like, now, to be fair, if you really like chemistry, you should do AP chemistry next year if you're going to do AP chemistry at all. That's because you don't want, there's a lot of things going in your head now that you're going to forget after a year away from it. I mean, if you really, really like AP chemistry, you may want to double up with physics. If not, take physics your senior year, you'll be fine.
I was going to take AP Bio.
Do you like AP Bio better than, Chem?
No, I like Chem better than Bio. Bio?
All right, then I'm not as sure as I was a second ago about the whole physics advice. Whoop. All right, what do I got here? I got, 30. So I have down that it's, closer to 30, 5.4. So I got 5.4 centimeters.
I got 6. I got 5.75.
Oh,
I got 5.6.
nice. Okay, everybody's getting a higher number than me. That means I'm probably 2. I'm not right.
So what am I doing wrong?
I didn't do anything wrong.
No, why am I doing
I don't disagree with that one. I'm okay with that one.
I got 5.2.
Oh, I got to draw a line between the two. 5.2?
I don't like
Well, I'm with you. You got the closest answer to the one I got.
Yes.
No, I'm not going to complain about what you're doing. Now I need my angle. Ooh, that's pretty close to 90. What's the angles? Lottie, what do you get for an angle? Woo, straight up, I got 90. I'm pretty sure I've never done that before. So,
I've got
90?
90 as well.
All right. Mr. Galati got it and I got it. That means there's a 50-50 chance it's right. All right, since we're having fun, go ahead and finish with number 7.
I got a really weird answer for 7. I don't like it.
There's a lot of really weird answers for 7. We're gonna not share them just yet. Yes. There's one answer that absolutely stone cold works. Depending how you do it, you might get a different answer. Then we've got y. It goes 3 this way. We get to the end of it. And we do z, where this is 45 degrees. This is also 45 degrees. That means that those alternate interior angles are equal, which means we're literally going back the way we came. 3 sets of 1, right? And so if you did it perfectly, you would get 0. Now, if you did it by drawing, there's a chance you ended up like here or here, and that's not great. So we want a better way to do this, do we not? So let's go a better way to do this. Are you ready? All right. Going to 4.2 now. Let's go to 4.2. You guys are going to get a little bit of a break at the start of next class period, just so you're aware. Take a nap, bring a cookie, get a sandwich. You can even get a big sandwich, I'm afraid. This is going to be way ahead of the class. That's why you don't ask no questions on your test. All right, 4.2. Sometimes, often, it is not practical to draw vectors or even a scale drawing of them. Instead, it makes sense to solve for them algebraically. We just solved this one algebraically, did we not? And we got a more accurate answer that we all be convinced it has to be more accurate. Is there Combs, you with me still? Okay. So let's try the next one. Bob, number 1. Bob is walking due north, that's 90 degrees from the standard position, for 40 meters. He then turns and goes east for 30 meters, 0 degrees from standard position. Where does he end up according to someone who was standing next to him at the very start? Questions to think about. Would adding 40 and 30 do? Would that actually tell us how far away he is? No, that would not do. And is it good enough to say when you get that answer, is it good enough to just give me a number? Or do you have to say, we say where, you have to tell me what the direction is? All right, have at it. We should try this problem. Person is walking 40 this way, followed by 30 this way. Probably better if I look at a little more scale. This is actually where they end up, relatively speaking. What do you got for me, sir?
50 meters at 52.1.
How do you get the 50 meters, by the way?
I did Pythagoras.
So we're going to go 30 squared plus 40. Can I do Pythagoras?
Yeah, because we have a 90-degree angle.
That's a nice 90-degree angle, north and east. I love that. Equals c squared. And so I do a little bit of math. I'm going to get 50 meters. 50, whatever these m's are. We don't know what those are. 50 m's. Good so far? What's my direction? You said what?
53.1 degrees.
How'd you get that?
I did like the
You're right. Just stick with it. Go tough.
I did the angle that we ended at. I like.
Oh, so you looked over here. No, you ended up here. You did here?
Yeah, I did that one.
What did you do that one for? Okay, you're wrong now. You got the right answer, but you got lucky.
I got the right answer.
This is our starting point, correct?
Yeah. No, it's because I drew my graph on. That's why. I did it west instead of east. So I got. That's how I somehow got it.
Now you said 3 wrong sentences. Now you still got the right answer, which is disappointing. I can't even tell you how many ways. Okay, first of all, I need an angle, don't I?
Yeah.
How can I get an angle?
Tangent.
I'm asking her now. How can I get an angle?
By using the things that I really, really just dislike.
Well, but you're going to have to use them now. So let's get on it.
Okay, so like tangent of
Opposite. So I got tangent of, we're going to call this theta now because we're getting to be grown-up kids. We're going to say tangent theta equals 30 over 40. So theta equals the arctan of 30 over 40. Get out my calculator. We're going to estimate to the nearest tenth. It should say that on this worksheet. It does not. I apologize. Arctan, arc answer. What'd you get? 0.9.
yeah.
Okay, 36.9 degrees. Okay, so
Oh, and then you just okay.
so that's 36.9 degrees. Now I'm switching off you to Cassini. That's not the right answer. Because we're going to measure it relative to 0 degrees in this class always. So we're going to come this way. And if this is 90 degrees, then 36.9 from 90 degrees would leave me with what left over?
53.1.
53.1. At 53.1 degrees. And I better put a line on top of that because it's now a vector.
Wait, couldn't you just solve for the Vecors called the endpoint angle? And you get the same answer?
You could have redrawn it as 30 then 40 and done it that way. And then the 40 over 30 arctan to 40 30 and done it. Could you have used this? Yes, because these two happen to be equal to 90 degrees, but I'm not sure what rule you like. It feels like luck, not skill.
Well, if it's a right triangle.
They would always have to 90, but why are you using this one not in this problem and not this one? Like the reasoning is a little bit shady.
Okay.
Just saying. I'm suspicious you may not know what you're doing. Okay, try